So in task 1, we spent a lot of time reversing our circle area and circumference formulae. Now we're going to reverse two other formulae, and they're the formula that we learned last week. So they are the arc length formula and the sector area formula. So here you can see that we've got a sector, we've been given an angle, and we've been given the arc length of that sector, but not the radius. Again, like we've just been doing with the circles, our first step in such a question is always to write down our formula. So arc length was equal to angle over 360 times pi d. And that's from last week. That's that formula that we learned last week. And it's one that hopefully you're beginning to become a bit familiar with. Now, we're going to work with that. So we're going to put in the numbers that we have. Same technique we just used with circles. We've got two numbers to put in here. The arc length, which is 25, and the angle, which is 80. Now, there's a couple of different approaches you can take at this point. The very mathsy approach would be to try and rearrange this. I'm actually going to take a slightly different method here. Because I noticed that all of this is numbers. We've got 80, divide it by 360 and times it by pi. That is all numbers because pi is just 3.14. So what I can do is just get out my calculator. I'm even going to use my phone one here. Okay, normally I'd encourage you to use a scientific one, but I know a lot of you are working with phone ones at home. So get out a calculator and do 80, divide it by 360, and times it by pi. All of those are just numbers, so it turns out a decimal for us, which is 0.6981317, etc. So we can rewrite this line as 25 equals. Now we need to keep a lot of accuracy at this point, otherwise things are going to go wrong. So let's keep as much accuracy there as we possibly can. Now, that's just a big number times d. If we want to solve that equation and work out what d is, we just divide both sides by our big number. So dividing both sides here by that 0.698, etc. And as I say, keep all the accuracy. You're going to have to divide by that whole thing. So doing that, we get that 35.809862195 equals d. So I've just divided 25 by 0.698, etc., and we get this number here. That's not quite what we're looking for because we were asked about r, so we need to half that. So if d is this number, then r is half of that. Again, just use your calculator to work that out. And then we want to round it, well, to the nearest two decimal places, that's 17.90. We were working in centimeters for our arc length, so our answer is also in centimeters. So there's our method. Same ideas, same key ideas as we had with circles. Write down our formula, put in the numbers we do know. This step's a wee bit different because I'm encouraging you to work out this as a number. It makes it a bit easier when we come to our rearranging steps. And then, like we did with the harder example in the circles one, we've just got to go from our diameter to working out our radius. So have a go. There is a sector, angle 140, and I'm going to tell you that the arc length for that sector is equal to 20 meters. And what I want you to do is find the radius. So very, very similar to what I've just done. Have a go, pause the video, and then I will give you the answer in just a moment. Great. Hopefully you paused, you've had a go, and now you'll be able to check your answer, check your method that you've just used. First thing we always do, write down our formula. So there is our formula. Might have it on the other side of the page, but still, that's our first step. Put in the things we know. So arc length is 20. Angle over 360 times pi d. And I spot I've made a mistake. I forgot to put in my angle. So that should be 140 in there. Okay, so just if you still have two things that are unknown, check back on your diagram. Is there something extra that you've missed? Again, I'm going to work that bit there out as a number. So 140 over 360, or 140 divided by 360 times pi. That should give me that 20 equals 1.2217347. Keep that accuracy high. Lots of d. Dividing both sides by 1.2217, etc., should give you the diameter was 16.37022218. Halving that to get our radius, we get our radius being 8.18511, etc. Rounding to two decimal places, 8.19. We started in meters, so our answer is in meters. Apologies, I just went off the bottom there. So hopefully it gives you a nice little method that we can use to reverse our arc length formula and find the radius. In video 2, you'll see that we're going to do exactly the same idea, but we're going to reverse our arc length formula to find the angle. But it's going to be quite a similar method and setup.